structures range from Matrix offers an affordable way to study 7 commonly taught principles of structures across college and university level. The 7 kits now available teach students the principles of bending moments, shear force, reactions of a simply supported beam, bending stress, deflection of beams, torsion of rods, and pin-jointed frameworks. Each of these 7 kits features a stiff, robust metalwork panel which is fitted with removable legs, a carry handle, and a plastic moulded cover, which is also used to protect the system from any damage when not in use. The panels can be connected to a power supply through a wall plug or by using a USB connected to a PC, which allows simultaneous data export to Excel for analysis. Each work panel is equipped with a built-in LCD connected to an onboard controller, which provides the user with a manual method of collating results from their experiments. As always, each kit comes supplied with a full, free curriculum offering worksheets, experiments, and teacher's notes. These are available online through our Learning Centre. The Bending Moments kit allows students to create positive and negative bending moments by applying different loads to a beam which is held between 2 supports. Students can then apply various situations and measure their results. These situations include varying single point load, moving single point load, multiple loads either side of supports, and single uniformly distributed loads or in superposition. Our Shear Force Kit allows for the principles of shear force to be explored. Using hanger weights along a beam with pinned and roller supports, different loading experiments can be conducted. These situations include varying single point load, moving single point load, multiple loads either side of supports, and single uniformly distributed loads or in superposition. Reactions of a simply supported beam. This kit allows students to explore the behaviour of reaction forces on a beam with supports. The beam is placed on precision load cells which measure the reactional force of the loading parameter, allowing students to explore both positive and negative reactional forces and the principle of superposition. The Bending Stress Kit provides students with a beam which has 4 strain gauges attached. Using equations for bending moment and stress, the theoretical value can be compared to the output. The strain gauges can be connected in 3 different Wheatstone bridge configurations, which allows students to explore the behaviour of quarter, half, and full bridge configurations. Deflection of Beams. This kit allows students to use a range of beams to understand the elastic properties of beams and cantilevers. Students apply loads to measure deflection, and this kit includes a set of different metals and different supports for comparison. It also allows the student to vary the length of the beam to see how this affects the magnitude of deflection for a given load. Our Torsion of Rods Kit allows students to understand the torsional elastic properties of rods by fitting a selection of test rods to the work panel and adjusting the distance between the chucks. Students use textbook equations to compare modulus of rigidity and predict the deflection and torque relationship and compare the calculated results with the measured results. Pin-jointed frameworks. This kit allows students to apply loads in different places on the pin joint framework to explore the tension and compression forces within each structure member. With 6 load cells and 2 hanging positions, students can explore the idea of redundancy in frameworks and how load is transmitted through the system. Students will learn to analyse the structure members using method of joints and method of sections while using Bose notation. All of these solutions are portable. They can be packed away and are rugged in their design to live up to the use of students in a classroom or laboratory environment. If you would like to know more about the structure solutions from Matrix, please don't hesitate to get in touch with us or visit the website.